Exploring NumPy's ufuncs. So ufuncs exist in two flavors, which are unary ufuncs, which operate on a single input, and binary ufuncs, which operate on two inputs. We can have the definition here. As you can see here. So we'll see examples of both these type of functions here. The first one is array arithmetic. NumPy's ufuncs feel very natural to use because they use of Python's native arithmetic operators. The standard addition, subtraction, multiplication, and division can be all used. Now we will use that. X is equals to np.arange, the bracket 4, print 1, 2, 3, 4, 5 is equals to print plus 5 equals to x plus 5. Now we'll copy that down because we only have to change the signs to subtraction. Now let's copy that down again. Now we have to change the sign as well as the number. We will use the asterisk, which is multiplication. We'll use 2. Again, now we will use divide sign. And now at the end we will use double slash. Now it gives the answer this. So there is also a unary ufunc for negation, double asterisk operator for exponentation, and a percentage operator for modulus. It is actually Mendisa, but we will write as the percentage. So now moving on to the functions, we will write print minus x, removing the double quote, 1, 2, 3, 4, 5 equals to minus x, print x 2 comma x double star or double asterisk, sorry, 2 print so this gives an output, this one. So in addition, these can be strung together however you wish, and the standard order of operations is respected. You can see here minus the bracket 0.5 asterisk x plus 1 asterisk 2. This gives the answer, this one. So all of these arithmetic operations are simply convenient wrappers around specific functions built into NumPy. For example, the plus operator is a wrapper for the add function. You can see here np.add gives 3, 2, 3, 4, 5. Okay, let's see some arithmetic operators implemented in NumPy. You can see here in the table. So additionally, there are Boolean and bitwise operators we will explore later on. We have explored. So now we will discuss the absolute value. So just as NumPy understands built-in arithmetic operators, that NumPy understands Python built-in arithmetic operators, it also understands Python's built-in absolute value function. We'll say x is equals to np dot array 2 minus 2 minus 1 0 2 1 0 1 2. So the corresponding NumPy ufunc is np.absolute, which is also available under the alias to np.abs, which is absolute. np.absolute array 2 1 0 1 2 and np.abs. This gives the same answer. So this ufunc can also handle complex data in which the absolute value returns the magnitude. Now let's see another code. X is equals to np dot array 3 minus 4 4 minus 3j 2 plus 0j 2 plus j comma 0 plus 1j. Sorry, it is j here. np.a absolute x. This gives the answer 5.5.2.1. Now we will discuss trigonometric functions. NumPy provides a large number of useful ufuncs, and some of the most useful for the data scientist are the trigonometric function. We'll start by defining an array of angles theta np dot linspace 0 np dot pi. Now we can compute some trigonometric functions on these values we have just put. So print theta 1 2 3 4 5 sine theta 1 space np dot sine print. Now we will copy that down here. You only have to change sine to cos. Now we'll change cos to tan. it gives the answer this. So the values are computed to within machine precision, which is why the values that should be 0 do not always hit exactly 0. Inverse trigonometric functions are also available. X is equals to minus 1, 1. Print x 2, 3, 4, 5, 6. Print arc sine and v dot I will change sine to cos, then cos to tan. Now this results in x is equals to minus 1, 0, 1, and then it gives the answers of inverse trigonometric. Now let's discuss exponents and logarithms.